Let's talk about file browsers. You know, something like Windows Explorer or the Mac Finder. The whole purpose of a file browser is to help you locate and organize your data. And if you're a data scientist, you probably have a lot of data. JupyterLab is the world's leading data science platform, trusted by countless data scientists, but its file browser needed some UX help. Files can be stored in many different locations, but they're broadly categorized as either local or remote. However, what's local or remote is in the eye of the computing beholder. JupyterLab understands files in relation to the kernel running JupyterLab, not in any physical sense. This is not how we humans think about file locations. As UX titan Don Norman reminds us, when there's a mismatch between the user's mental model and the system's image, bad things happen. And that's exactly what was happening with JupyterLab. Our challenge was to find a way to match the Jupyter file browser system to the user's mental model of how a file system should work, to provide visibility into the true location of a file, and to give data scientists access to all their data in a single place, regardless of its true location, but without adding unnecessary complexity to the user's experience. This was a serious challenge. We needed to thread a UX needle.
Our research revealed the problem to have three key components: ceilings, bridges, and spaces. We needed to devise UX solutions to each of these challenges. At the core of this mental model mismatch was the ceilings problem. Users expect that they can access all of their files on their local machine through a file browser. But JupyterLab was blocking its users from accessing any directory outside of those that were subordinate to the current working directory from which JupyterLab was running. Imagine if your Mac Finder or Windows Explorer wouldn't let you access your files. This ceiling was an artifact of an older version of JupyterLab that was no longer necessary. It was time to break through the ceiling. Then, there was the bridges problem. Today's data scientists store files not just on local drives inside of or physically connected to their machines, but also on cloud storage platforms like Google Drive or Amazon S3. And JupyterLab had no easy way to bridge connections to those external file locations. The bridges problem resulted from the significant popularity growth of cloud storage platforms in the past few years. JupyterLab needed an upgrade to enable this new way of working. Finally, our research revealed that JupyterLab users were also seeking a way to collect relevant files together by concept, without having to create duplicate copies of each file. Data science projects can often involve ingesting the same data set for many different purposes. Other file browser systems have recently developed methods to allow users to create Venn diagram style groupings without having to change the file's location or create redundant copies of it.
Because of these problems, JupyterLab users were reverting to suboptimal workarounds that ultimately generated even more UX problems down the line. Attempting to avoid the ceiling, to deal with the lack of bridges, and to create spaces in the only way they had available, JupyterLab's users were copying their data files from their original locations, creating redundant data files, and assembling their own special folders for each data science project. This Band-Aid workaround ended up multiplying the UX pain, because each time the data set was updated, the frustrated user was forced to remember each place she had put the data set beforehand, and to manually update that copy. In short, these problems forced the user to create a mental treasure map of each place she had put her relevant data, and then also to keep that map constantly up to date. And of course, if the user forgot to update any one of those duplicate copies, any outcome generated from that now obsolete copy could be corrupted. Other times, users were attempting to avoid these UX roadblocks by running multiple instances of JupyterLab from different directories. This workaround was inefficient and frustrating, especially for those data scientists who need every ounce of computing power that their machines can muster.
Our solution focused on these ceiling, bridge, and space issues to solve the biggest shared user journey pain points across all 4 personas that we unearthed during our UX research: finding files and organizing files. First, we made certain that our iteration of the file browser would have the technical capability to go above and beyond the current working directory from which JupyterLab was launched. We provided the user with full visibility into their local file system, exactly as they'd expect. Second, we built a new flow that allows JupyterLab users to connect to cloud-based data sources that they commonly use, such as Google Drive or Amazon S3. Third, we address the user desire for spaces to organize files that are related by concept. We interfaced with another JupyterLab project regarding workspaces to learn how our solution was similar to and different from that effort. Advancing the ball in this area, our spaces concept gives the user the ability to organize files without having to open them all simultaneously, eliminating computing resource drag as well as the risk of inadvertently modifying or deleting the data. Finally, we address the need to sharpen or add common file browser features into JupyterLab. For example, we created a preview file functionality. Data science files can be enormous, and opening the wrong one can be a real pain. Allowing the user to see what's in a file before opening it is a user-delighting but previously missing feature.
Success in this project had to be measured by more than just timely delivery of the product. As an open source project with a passionate and dedicated user base, JupyterLab's strength is the strength of its volunteer leaders. We worked closely with those key stakeholders to build a product that advanced JupyterLab beyond its file browser UX challenges, while minimizing unnecessary change for experienced Jovians. Despite a once-in-a-century global pandemic that eliminated any possibility of in-person research or work, and despite the fact that none of us are data scientists trained in working with a product as powerful as JupyterLab, we delivered an impactful solution that will help JupyterLab data scientists navigate the burgeoning field in a faster, easier, and better way. Thank you to everyone for all of your support and guidance during this project.